Water not only quenches thirst, but also makes clean all the things with which people work and live. So water treatment must be tailored to fit local conditions.
Well, water quality and water quantity issues are just obviously important to people, but it's more than that. We're talking about the life support systems of the planet. But water affects us in our long-term health, and sometimes short-term health, with the contaminants that are already there.
What we put into the water invariably comes back into us through the rainfall and the water we drink and the exposures we have when we're swimming in the ocean or in our streams and lakes. And industrial pollution and consumer society have unfortunately toxified all of our bodies of water around the planet.
So depending upon where you are in the country, the effluent from one city becomes the drinking water for another city. Enter pharmaceuticals and trace contaminants, which was not part of any of our design criteria for designing these systems.
There's some trace contaminants that are in our wastewaters that these conventional processes that we use today are not removed. Some of these end up in our surface waters and are taken into our drinking water treatment plants.
Industrial waste from a number of different industries, the landfill leachate that may be piped through wastewater treatment plant, household wastes, those chemicals from a number of different sources are aggregated again. The chemicals that aren't removed in treatment pass through and may enter our streams with the wastewater discharge.
So anytime there's a hard rain, everything ends up going downstream, collects all the heavy metals, the oils, the pesticides, the fertilizers, you name it.
Because we're using so many chemicals that might be dissolved in water, or for example for agricultural chemicals, might run off of fields, or in the case of pharmaceuticals, end up in our wastewater, all that gets all mixed up together. So on the one hand, I guess there are chemicals that are desired for their pharmaceutical or for their agricultural uses, but we have to realize that they end right back up in the stream that will become our drinking water and the water, for example, that we would supply to animals in agriculture, and that generates a problem.
The issue of how disinfectants then react with those compounds that are not removed by the process, and what those byproducts are and what their risk is largely unknown. I mean, individual chemicals have been studied, not mixtures.
But again, if we use a chemical, it's pretty likely that it's going to enter the environment and we're going to be able to measure it. And that's not the point at which to be concerned. That's sort of a given. The point at which to be concerned is when it reaches that threshold and it's at a level that's not appropriate. And that's what we really have to focus on.
And they do find a lot of contaminants in our water supply today. And I can understand how important it is to treat it, even if we are getting all those chemicals inside of us. However, one chemical in particular is not being placed there to make our water any safer or cleaner. Apparently, our water supply is the only place that we can put this.
Have you ever heard of a thing called fluoridation? Fluoridation of water?
Yes, I have heard of that, Jack, yes.
Well, do you know what it is?
It finally got the green light from the federal government in 1945 following a release of a large amount of hydrogen fluoride from a Deepwater, New Jersey plant of DuPont in connection with our production of uranium for the nuclear weapons program in the Manhattan Project. And at that point, the government circled the wagons, if you will, here in D.C., the Food and Drug Administration, the Public Health Service, the War Department, as the Defense Department was known then, decided that they couldn't have the defense contractors that played such a vital role in our nuclear weapons program be subject to these kinds of lawsuits. So I said, well, why don't we start cleaning up the image of fluoride by putting it in drinking water systems in a couple of cities and see how it goes.
And they basically steamrolled it through into the federal government policy. And once the government and their corporate backers and their dental backers decided on fluoridation, they closed off all options for revision. They closed off all possible research to open up questions about fluoridation, and they harassed their critics. So it was just the opposite of what a scientific process should be like.
This is a silly thing to do, because once you've put your medicine, whatever you want to call it, drug, nutrient, in the water supply, you can't control the dose, and you can't control who gets it. It goes to everybody. It goes very young, very old, very sick, people with poor nutrition. You ask a pharmacist, ask any pharmacist, Doc, is there any drug in this store that you can say everybody can have this drug, and everybody can have this drug without controlling the dose? And they look at you as if you were stark raving mad, which is what you are if you do that.
In the beginning, sodium fluoride, largely from the aluminum industry, was the chemical that was used for adjusting the fluoride levels in drinking water supplies. But by the late 40s, it became obvious that there was another source that would be cheaper, namely the byproduct from the phosphate fertilizer manufacturing industry.
If you ask most dentists and ask them what they're putting in the water, most dentists would say sodium fluoride, pharmaceutical sodium fluoride, the same stuff that is in toothpaste.
They have absolutely no idea that it's, in 9 out of 10 cases, hydrofluorosilicic acid, and that hydrofluorosilicic acid is a waste product for the phosphate industry.
If that stuff goes out the stack, it's an air pollutant. And if they try to discharge it into the nearby river, it's a water pollutant. But if they put it in a tank wagon and sell it to your water authority for $500 to $1,000 a ton, and then bleed it slowly into your drinking water system, like magic, it's not a pollutant anymore. It's a product. And the phosphate industry walks away with $200 to $300 million a year in pure profit from that.
Now, what we've got in this country is a ridiculous experiment, which is compounded by the fact it's a lousy experiment because we're not even collecting the data. And we've got ourselves now into this situation where the most rational interpretation of what's going on right now in the United States and other fluoridated countries is that the health authorities are more concerned about protecting this practice than they are about protecting the health of the people in their country.